Welcome to physics online session. Today we will discuss first chapter from semester 1, that is physical world. Since physics is the branch of science, first we have to know what is the science. So science, the word science originated from the Latin verb scientia. Scientia nothing means to know, and it originated from the Sanskrit word vignan and Arabic word ilm, so convey the similar meaning, knowledge. Okay, so the world around us, we can see the world around us, and with which we can interact with our physical sense organs, eyes, ears, etc. So the world is said to be the physical world. Okay, and we will try to understand what is happening in the physical world, how the things are happening, like falling of an apple onto the earth. So how the planets are revolving around the sun. Okay, so we observe these things, and so we will develop our knowledge systematically. Okay, so this is known as this knowledge, whatever the systematic knowledge is known as a science. So it is defined like that. So science is an organized knowledge. Okay, and it is, science is dynamic. Science is dynamic, it is not static. Okay, if one scientist invented one thing, so the better invention come in the future. Okay, so it always progress. Okay, so science is a dynamic, not static. Okay, so here, in order to understand the natural laws, so related to science, laws related to science, so we follow one method that is called scientific method. So scientific method, it is a actually science is a systematic, scientific method is a systematic attempt to understand a natural phenomena. Okay, in order to understand any natural phenomena, formation of rainbow, any phenomena, falling of an apple onto the earth, we must follow these steps. Okay, first what we do to when you try to understand one thing, first we will do observations. So example, same example, falling of an apple onto the earth, and formation of rainbow, flowing of water from hills to land areas. So let us take this example of flowing of water in the river. So in India, most of the rivers, I will give the directions here in Indian. So this is east, west, north, south. Most of the rivers flows towards east. Okay, this is one observation. So but it is not always true. Most of the rivers flows towards east, so water flows towards east. It is always not correct. Okay, so some rivers flows towards west, some rivers flows towards south. Okay, so etc. Here, so these are the observations. Okay, so and we'll do, based on these observations, we'll do experiments. Okay, so we take a test tube, any tube or any pipe in the laboratory. So we'll do experiment, controlled experiment. We'll put some water here, and this is at a greater height and lower height. So okay, H1 height, H2 height, H1 is greater than H2. This end A is at higher height, higher altitude, and it is at lower height. So when you put some water at here, so definitely it comes out from this second end B. Okay, we can say that so from this observation we can say the water flows from high level to low level. Water flowing from high level to low level, not it is not flowing towards right, left, east, west, like that. It flows, water always flows from high level to lower level. So we put a test tube in different directions. So whatever the direction it is, east, west, north or south, it always flows from high level to low level. This is our observation. So control this based on these observations. This is our point. Okay, water flows from higher level to lower level. Okay, next okay, so here no, next step is analysis. First we will do observation, different observation with the we observe the flow of water in different rivers, and we will do experiment in the laboratory, and next we will analyze qualitative and quantitative reasoning, the process of analysis. Here we will take even the, for example, with any electric motor, if you maintain high pressure here, high pressure, somehow we are maintaining high pressure and here low pressure, what happens to the water? The water starts flowing from B to A. Okay, so it is always not correct. Water always flows from high potential to low potential. There are some constraints. So when you maintain a high pressure at the bottom and low pressure at the top, even though water flows from lower level to higher level. Based on this analysis, will make mathematical formulas, mathematical modeling. Okay, we'll make some formulas. Okay, and we based on that formulas we can predict. Okay, if you know the pressure at the top and bottom, we can predict so where water flows from where which point to which point. We can predict the flow of water in rivers or any. Okay, and if our prediction is correct, if the prediction is correct, so then that is verified. Okay, that observation, so that experiment is verified. If it is wrong, if it went wrong, it is said to be falsified, so it become hypothesis only. So okay, so okay, next if it is verified, it become a law. Okay, if someone observed based on observations, if someone gave some points, water flows from higher level to lower level, high pressure to low level, if it was not proved, if it is not proved, then it become a hypothesis. When it is proved, it become a law. Okay, that is the difference between hypothesis and law. Okay, next this is about how to understand the physical phenomena and natural phenomena. It is a systematic attempt to understand natural phenomena, scientific method. Okay, next so I am coming to our actual topic. What is physics? What is physics? Physics is the study of a natural world or physical world around us and the basic laws of nature. It is a study of a physical world and the basic laws of nature and their manifestation in different phenomena. How the phenomena changes, how the basic laws of nature laws changes in different phenomena. That is what we are going to learn in physics. That is defined as physics. Physics is the study of physical world and basic laws of nature. Okay, next we can also define physics in another way. Physics, it is the branch of sciences, so which deals with the different forms of energy and matter. This is what we are going to learn in physics. Okay, so what are the different, what is the energy? The capacity to do work is nothing but energy. Okay, energy expressing in terms of work only. Even though you have some energy, if you are not expressing or not doing any work, we can't say whether you have energy or not. Okay, so the capacity of doing work is nothing but the energy. Okay, so now look at these different forms of energy. The energy has different forms. Energy neither be created nor be destroyed. It has but can be converted from one form to another form. So now let us see the different forms of energy. Mechanical energy, it is of two types, kinetic and potential energy. Okay, if the energy is associated with the static bodies, water in a dams has a potential energy. So but when the dam gates are opened, so water comes out and strike the turbines. So what happens, the potential, whatever the potential energy is converted into potential energy, because it is rotating the turbine. So this is about the mechanical energy. Okay, so and next for the next form of energy is a heat energy. So from this mechanical energy, we will study about mechanical energy in the first year PUC 1 up to 11th chapter. So starting from motion in a plane to motion in a straight line to mechanical properties of fluids, we will study about the mechanical energy. That comes that those 11 chapters comes under mechanics. Remaining 3 chapters, thermodynamics, kinetic theory of gases, thermal properties of matter. Three chapters comes under thermal physics, so where we discuss the thermal energy or heat energy. Next, light energy. Light is also a form of energy. Okay, light is a form of energy. It makes us the things visible. Light itself is invisible but makes other things visible. Okay, it gives a sensation of vision. Okay, we'll discuss this energy. So this branch related to light is called optics. We will discuss this branch in the second year. We have 3 chapters from 2 chapters from this light energy in the second year. So and electric energy also we will discuss it in the second year only. In the first year we will discuss mechanical energy and thermal or heat energy. Okay, so what is a matter? Anything. So you have studied one basic definition in your lower classes. Matter nothing but anything which occupies some space and having some volume, having some mass, and is said to be the matter. Anything which occupies some space and having some mass is said to be the matter. Matter can exist in generally 3 states: solids, liquids, and gases. There is a 4th state of matter that is called plasma. It is a state of ionic matter. Okay, we will discuss about the mechanical properties of solids in the 10th chapter, and mechanical properties of fluids, both liquids and gases, in the 12th 11th chapter. Okay, so we don't discuss this plasma state here. It is a state of ionic matter. Okay, so this is about the physics, what we are going to learn in the physics that is defined as a physics. Okay, next the branches of physics, as I told in the previous session, so previous slide. So physics is of different branches: mechanics, okay, electrodynamics. So optics is a branch we discuss light energy, thermodynamic, thermal energy, and this is third next branch of energy, quantum mechanics. We will discuss in the next topic about this quantum mechanics. These are the different branches of physics. Okay, and next domains are different regions of physics. So it is of 2 types: macroscopic domain and microscopic domain. In this domain we will discuss the motion of large bodies, so stars, planets, stars. Okay, so in this region we will discuss the motion of objects which are either visible directly with a naked eye or can be made visible by using optical instruments like a microscope and telescopes. Okay, it is the branch of large particles. So the mechanics is called classical mechanics, so where we use Newton's laws to know the motion of those large bodies. Okay, next domain is microscopics, where we studied the smallest particle, atoms, molecules, and electrons, protons, neutrons, what are the properties, what are their properties, and we can study the motion of those particles. Okay, even though we cannot see them, but we can study with the help of some principles, and that branch of physics is said to be the quantum mechanics. It is a branch of smaller particles. Okay, this is about the domain or branches of physics. The next one, so here one question from this one question may come from these fundamental forces in one of the exam, MT exam only. So look at this fundamental forces. What are the fundamental forces in nature? What is a force? A simple definition you have learned in a lower class, that is a push or pull is said to be a force. If you pushing or pulling any body, so you have said to be applied a force on it. Okay, when you apply force on it, what happens? It moves. Okay, so there are 4 fundamental forces in nature. Okay, so the gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. These are the 4 fundamental forces in nature. Okay, so and here we will discuss the gravitational force. Okay, so example, when apple fall onto the earth, why the apple falling onto the earth? Because earth attracts. So rain falling because earth attracts. Planets are revolving around the sun because, so why the planets are revolving around them? The reason is also same, because, so why earth is attracting? Because there is an attractive force between. So Newton proposed that not only earth attracts bodies, any mass particle attracts another mass particle with some force, that is called gravitational force. Any mass particle. So this law is universal in nature, it can be applicable anywhere. Okay, so here, okay, so the main source of this gravitational force is mass. Okay, any mass attracts another mass, any mass attracts another mass with some force, that is called gravitational force. Okay, what is the source of electromagnetic force? Here, charge. Like charges attract and unlike charges, like charges repel, unlike charges attracts. Okay, we have studied about the charges in your lower classes. Okay, so like poles are magnetic force, electric force exists between charges, magnetic force between 2 magnets. Okay, so here electromagnetic force, whatever it is, the source of electromagnetic force, whether it is electric or magnetic, so the source is charge. Okay, so like charges repel and like charges attract. I am writing the source second point. So this is always attractive, there is no repulsive force in case of gravitational force. Gravitational force is only attractive, it is only attractive. Okay, either attractive or repulsive. Okay, what is the range of this gravitational force? Range is infinite. Infinity, it is applicable anywhere. Okay, so sun, so all the planets are revolving around the sun because sun is exerting some force, gravitational. There exists a mutual attraction between the earth and sun. There exists a gravitational force between the sun and earth, even though distant star, okay, even one star attracts another star also. Okay, so it is applicable anywhere, it is universal. Gravitational force is applicable anywhere. Okay, so long distance star also experiencing some small force on us. Moon is attracting us with a small force. Okay, but there is a force, but it is negligibly small, but there is an attractive force on us. Okay, if the stars are attracting, planets are attracting. Okay, so the range is infinite. And what about the range of this electromagnetic force? Here the range is also infinity. Okay, large distance can also experience this attraction or repulsive force. So I forgot to write the points of this nuclear force. Here within the nucleus we can find within the nucleus. So actually this is a range. So right. Okay, it exists between the nucleons, nucleons nothing but neutron, proton, etc. Okay, nucleus has only these two particles, primary particles, neutrons and protons. Electrons are revolving around the nucleus. Okay, between the nuclei, it exists between the nuclei. This is also between the nucleons. Sorry, nucleons. Okay, so this is only attractive. This is also only attractive. The range, these exist within the nucleus. Within the nucleus, these forces also exist within the nucleus. Within the nucleus. What are the nuclear force? For this is an atom, this is a nucleus, exist and protons and neutrons. I am taking helium 24. Helium has 2 protons and 2 neutrons. The helium nucleus has 2 protons and 2 neutrons. Actually, these protons are positively charged particles. Okay, so these are positively charged particles. What type of force exists between them? So charge, because of its charge, I told that like charges repel. So they will repel. They are at a very small separation. There exists a lot of repulsive force between them. Instead of despite of this repulsive force, they are stable. Nucleus is stable. They are not going. They are not moving away. So if electromagnetic force or electric force only present between the proton, so nucleus may breaks. It will be broken, but it is not happening. Why? Because some other force is also present, which must be attractive to balance this repulsive force. That is a nuclear force, and the strength of this nuclear force is very large. It is 100 times larger than the gravitational force, this electromagnetic force. The nuclear force is stronger than 100 times stronger than electric force. Okay, right. And this about, what about the gravitational force? It is the weakest of all three. This is the weakest of all, and it is 10 power of 36 times than that of the gravitational force. Gravitational, it is huge compared to gravitational force. Electromagnetic force is very huge, very strong, but compared to electric force, nuclear force is much stronger. So nuclear force is 100 times than that of the electric force. Okay, so weak nuclear force exists in certain nuclear reactions. No need to worry about these weak nuclear forces in a beta decay in certain process. You don't know what is beta decay right now. So certain nuclear reactions you will see the weak nuclear force. It is also short range. So okay, the range is, these are the short range forces. Range is very small. Okay, next about just look at the stable gravitational force. Gravitational force is strength compared to the nuclear force. If you take a nuclear force as one unit, okay, and electromagnetic force is 100 times less. Nuclear force is 100 times strong as compared to electromagnetic force. Electromagnetic force, when compared to strong nuclear force, 1 by 100 times than that of the nuclear force. Weak nuclear force, 1 by 13 times than that of the nuclear force. So here the strongest in the order, nuclear force is stronger than the electric force, is stronger than the weak nuclear force. It is stronger than the gravitational force. These are the strengths, these are the ranges, and these are the where they exist. Okay, so the range of gravitational force infinity, electromagnetic force is infinity, and the nuclear force is short range. It is short range, it is very, very short. Okay, and so all these objects we will discuss these forces in detail when in the chapters like gravitation. We will discuss about the gravitational force, and nuclear forces we will discuss it in the second year. There is a nucleus chapter, there we will discuss the these forces in detail. Just in this class, just try to remember the ranges and the strengths and their sources. Okay, what I am telling, the range of the force, strength of the force and their sources, where they exist. Okay, gravitational force undalante there must be a mass, electromagnetic there must be a charge. Okay, where these nuclear forces exist, between the nucleons, neutrons and protons. Okay, within the nucleus only. Okay, so this is about the fundamental forces. Okay, so fundamental force, gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. Okay, and the next, the last topic that is what I am going to discuss in this class. That is, so there are two areas of physics, how to study physics. So here, that is called unification and reductionism. So for example, what is unification? Application of minimum laws to explain maximum phenomena of nature. For example, apple is falling onto the earth, rain is falling, all the planets are revolving around the sun. Okay, so these attractive forces. So why we are walking comfortably on the earth? Because sufficient gravitational force is there. Okay, so and all, if you are able to explain more large number of physical phenomena or natural phenomena in the nature with a very less number of principles, then it is said to be unification. Okay, certain principles, with a certain principle we can explain, with a 10 principle, let us take with a 10 principle we can explain, if you are able to explain 1000 phenomena. Okay, so that is called unification. Okay, and the next one is reductionism. For example, there is a complex system. Okay, so sending rockets. In order to send rockets, rocket design engineer, propulsion engineer, electrical engineer, electronic engineer. So there must be different steps are there. Okay, so one problem is sending rocket is divided into different branches. For example, when you burn coal, so our aim is to generate electricity by burning coal. Okay, we cannot explain this with a one principle. Why? It is a complex system. Okay, so when you burn a coal, what happens? Its chemical energy is converted into heat energy. Okay, so chemical to heat, one transformation. We have to apply a certain principle to explain this transformation, energy transformation. Okay, so here we need to apply some set of principles here. Okay, so conversion of chemical energy into heat energy, this is one process. Okay, and this heat is given to water boilers, water in the boilers, and that water converts into water vapor. Since water vapor has highest capacity of heat, it can take more amount of heat. Okay, it converts into vapor jet, high pressure vapor. Okay, this when high pressure vapor hits the turbines, they will rotate. Turbines will rotate. Okay, what is happening here in the second step? Here heat energy is converted into mechanical energy. Here we need to apply some second set of principles here. Okay, so we are dividing the biggest problem into small problems to understand the properties of a complex systems. So what happens, we have to understand the properties of the simpler parts. So the conversion, so chemical to heat and heat to mechanical. Next, what happens when turbines rotates? So due to electromagnetic induction phenomena, so this mechanical energy is converted into electric energy. Here we need to apply another set of principles here. Okay, so we cannot explain this phenomena, production of coal, production of electricity from coal with when very few principles. We need to apply large number of principles. Okay, so that is why when you applying a large number of principles, we need to divide this into different parts. When sending rockets in ISRO, so there are different scientists are there. One electrical engineer, so in order to design the structure engineer, in order to study about rocket motion, propulsion engineer, engine, about propulsion engineer, and electrical engineer, communicational engineer, etc. So different branches will be there. We will divide a problem into different parts. Okay, so we can study easily. This is about the different thrust areas of physics. This is about the natural world, physical world. This is about the just no need to worry about this. Just try to understand what is science. Okay, means it came from the Latin word, and meaning to know, and Sanskrit word Vignan, the Arabic word means the same meaning, knowledge. So what is the definition of science? Science, it is an organized knowledge, and it is a dynamic, not a static. It progresses continuously. In order to understand this natural phenomenon and the rules related to it, so we have to follow one method, that is called scientific method. Okay, and this includes, these are the steps that method includes: observations, controlled experiments, qualitative and quantitative reasoning, nothing but analysis, mathematical formulas, prediction. If the prediction is correct, it become verified, or it is falsified. So and when it is verified, it become a law. When it is not verified, it become hypothesis only. What is the physics? Physics is the branch of science which studies the physics is the study of physical world and basic laws of nature. It can be defined in another way, that is, the physics is the branch of science which deals with the different forms of energy and matter. And we know what is energy and what is the matter already I defined. So these are the different forms of energy and matter. Okay, and the scope of the different branches of physics: mechanics, electrodynamics, optics, thermodynamics, quantum mechanics. So domain, two ranges of physics: macroscopic physics, macroscopic nothing but classical mechanics, which uses Newton's laws; macroscopic mechanics, quantum smaller scale. So quantum mechanics, it uses Einstein principles, etc. Okay, and the next one, gravitational force. There are four fundamental forces in nature. So in mechanics there are different forces: mechanical force, frictional force, tensional force. These are different forces. They are mechanical forces. We are not talking about those forces. We are discussing basic forces in nature, fundamental forces in nature: gravitational, electromagnetic, strong nuclear force, weak nuclear force, etc. Okay, so what is the source of gravitational force? Mass. Source of electromagnetic force? Charge. Source of nuclear force? Protons and neutrons. So and this source here, during certain reactions only we can see these weak nuclear forces, and these are the ranges, strengths and the sources of these forces. Okay, next, this unification and reduction. There are two ways to study physics. This is about the first chapter, physical world. Okay, so this table is very important. You may get 2 marks question or 1 mark question in empties only, not more than that. Okay, so thank you.